So number 11 says, in the equations above, B and C represent the price per pound in dollars of beef and chicken respectively, X weeks after July 1st during last summer. So that's a whole bunch of stuff to say. Last summer, this many weeks after July 1st, these were the costs of beef and chicken, okay? So now their question is, what was the price per pound of beef when it was equal to the price per pound of chicken? So my beef is 2.35 plus 0.25x, and my chicken 1.75 plus 0.40x. Now, does anyone want to take a guess at what we're supposed to be doing here to solve this problem?
Chicken.
I want you guys to answer. You can put it in the chat if we're experiencing some crazy echo.
Ashley said that she thinks it's like the wood from number 9.
So, okay. I think what's happening is that, I don't know, I was going to say something about picking up mics, but no, so it's system of equations was number 9. It's not the same, right? So I'm looking for when they are equal to each other, right? So I'm going to do 2.35 plus 0.25x equals 1.75 plus 0.40x. Do we see why? I'm looking for when the prices were equal. So in order for me to find out when the prices were equal, I need to set my two equations equal to each other. Okay. So now it's all about combining our like terms, combining our x's and our x's, and combining our non-variable numbers with our non-variables. So I want to start off by, first I want to make it easy for myself, right? I want to make sure that when I'm combining these numbers, that I'm going to keep in my positives, right? So for example, what number do I want to move over? I'm going to just look at my numbers that are without a variable. Which is the number I'd want to move over so that I'm still positive? Come on, guys. We got to be a little bit focused. Or again, I can do silent notes even here. So I froze. We have to figure this out. So what can I do so that my answer is going to stay in there?
Combine like terms.
Okay, so I want to combine my like terms, which we can agree. Here's one set. Here's the other set. Right? We've got one that's without an x and one that's with the x. So if I want to combine my 2.35 and my 1.75, I want to move my smaller number to the bigger number so that way I don't have to go through dealing with any negatives. Okay? So that means I'm going to subtract 1.75 to both sides. That's going to cancel out. And what are we doing here? 1.7, remember there's no calculator for this. So we've got to kind of go through it without the calculator's help. So 5 minus 5 is 0. I have to borrow from here. 13 minus 7 gives me, you guys can put it in the chat too, but I do need some response here and there. Or again, I can do this silently. It's not going to be fun.
Could you repeat the question?
13 minus 7.
Isn't 13 minus 7 6?
Yes, it is 6. 1 minus 1 is 0. So I'm looking at 0.60 plus 0.25x equals 0.40x. Okay, now I want to move over this 0.25, so I'm going to do the opposite and subtract it from over here. That leaves me with 0.60 is equal to what? So I'm going to go ahead and borrow from my 4. That gives me 10 minus 5, which is still 5. 3 minus 2 is 1, and 0. So 0.15. Okay. Now, what's my last step? We should be used to seeing this already.
Divide.
Divide.
Divide by
Divide
0.9.
15 on both sides.
15 on both sides, which would leave me with x equals, now I have to go ahead and do the old-fashioned way of 0.60 divided by 0.15. Now, 15 can go into 60, but 15 is not one of the times tables that we're usually used to. So my advice to you, especially on stuff like this, so this, remember, this portion of the test is no calculator. So you have to do everything by hand. There's no way around it, okay? My advice to you is when you're looking for something like that, and it's the numbers that are bigger than 12, right? Because we pretty much all know up to our 12s times tables. What you do, my advice to you, is you do 2 and 5. Right? Everyone knows their 2's times tables. Everyone knows their 5's. So you would do 15 times 2, and you do it the old-fashioned way. You don't have a calculator. It's not going to be very fast. So that's going to give me 30, right? 2 times 5 is 0. I carry over my 1. 2 times 1 is 2, plus that 1 gives me 3. So I'm at 30. So I should already know that 30 is pretty close to 60 if I were to double it. But let's say it didn't work out so nicely. I can do 15 times 5, right? This answer, this 30, tells me that my number needs to be multiplied by something greater than 2, okay? Now, before I go and shoot for a 7, which is an obnoxious one to do, I'm going to go with a 5, right? 5 is halfway between. So 5 times 5 is 25. 5 times 1 is 5, plus 2, 75. So I know my number has to be either 3 or 4. Okay, I'm in the middle there. With that 15 times 2 that gave me 30, I'm going to go ahead and try 15 times 4, which would give me 20 here. 2, 4 times 1 is 4, plus 2 more is 60. So x equals 4. Yes? I feel like we're very distracted. And I am concerned about this. I'm going to move on, but we do need to pay attention. Okay. So my x is equal to 4, but I'm not done with my problem. Remember, my problem says, what was the price per pound of beef when it was equal to the price per pound of chicken? So now I have to go back and plug in 4 to my original beef equation. So my original beef was B equals 2.35 plus 0.25 times 4. Okay, so 2.35 plus 0.25 times 4. Now I don't even need to do the multiplication of 0.25 by 4 because a quarter is 25 cents. If I have 4 quarters, I have what?
A whole.
I have a whole, I have $1, right? So 0.25 times 4 is going to be 1.
3.35.
3.35. Or what letter is that one? That one is D. 3.35. We're good? Is that Gabby on your sharing your screen, Ashley? Okay. That one's not too bad. A few steps to do, but it's not so bad. Now, number 12. So number 12 says, a line in the XY plane passes through the origin and has a slope of 1/7. Which of the following points lies on the line? So I'm not going to waste my time doing a graph with this. I'm just going to do my t-table, right? My X and Y. Now they tell me it starts and passes through the origin. What point is my origin?
0, 0.
0,0. So that's where I'm starting. Now my slope is 1/7. What's my other way of saying slope? That's 2 words, well, 3 words technically. Something over something. Begins with R.
Ashley said rate of change.
But no, although that is 3 words, but 2 of them are R's and the third one is an O. The one in the middle is an O. What is the one that we learned?
Rise over run.
Rise over run. So my rise, which it's a positive, so it's going up, and my 7 is also positive, meaning it's going where? To the right or the left? Positive 7 goes where? Right or left? You can use the chat. I'm assuming you guys are pointing to the right because in my view, you're pointing to the left. So I'm assuming, yes, we are going to the right. Now, all I'm gonna do, so my X is +7. So remember, this is for my X and this is for my Y. So my Y is gonna go +1 and my X is going to be +7. So that's my second point. Is that any of the options they give me? No, so I'm gonna keep going. I'm gonna add another 7. So 7 plus 7 gives me 14. And I'm gonna add another 1. So 1 plus 1 is 2. Now, do I see 14, 2?
No.
What?
14,2 is letter D.
14, 2 is there. It is D. I'm done. I would basically have to do this until I found one of those points. You just keep adding 7 to your X and you keep adding 1 to your Y. So I know this is a little weird having to do it on Zoom, but it's temporary. We're doing the best we can. So it'll be better next week when we start getting into the habit. But I do see a lot of distractions going on in the background. So yeah, but we're gonna keep going. So that was 12. Number 13. So number 13 looks very, very, I don't know, horrible, scary, whatever we want to call it. It does not look very fun, but it's not that bad. Okay, so we have 1 over x plus 2 plus 1 over x plus 3. But the nice thing is it says, if x is greater than 3, which of the following is equivalent? So I can pick whatever value I want for x as long as it's greater than 3. So what number would I want to use? What number?
3.
No, I can't use 3. It's greater than 3, not greater or equal to 3. What number greater than 3 do I want to use for this wonderful little problem?
6.
Oh my gosh. Forget you guys. I'm using 4. I'm not going to go 6. I could, but I don't need to. Okay, I just need to go 4. I like the enthusiasm, but we're going to keep it simple. Okay. So we're doing 4. Now, this we can agree it's a little bit intense to look at a fraction with 2 fractions in the denominator. So I'm just going to focus on the denominator for now, okay? So I'm going to only look 1 over and replacing my x with 4 plus 2, plus 1 over 4 plus 3. Now I'm just going to work with this for now. So 4 plus 2 is?
6.
6. And 4 plus 3?
7.
7. Now I can just add my fractions. This should be something that we're familiar with. Now remember, when we add or subtract fractions, we need to have the common denominator. Yes, Trinity.
Why did you use like 4? I have a question. Yeah.
Why did I use 4? Because I could. The question says x is greater than 3. So I can pick any number I want that's over 3. I'm just keeping my life simple and just picking the first one above 3, which is 4. I could have done 5, I could have done 6, I could have done 10, I could have done whatever number I wanted, as long as it was greater than 3. Okay. Now, so I need to get my common denominator. So what number do 6 and 7 have as their greatest common denominator?
42.
42, right? 6 and 7 don't have anything in common unless they're multiplied by each other. So I have to multiply this by 6. And remember, what I do to the top, I do to the bottom. So 7s are multiplied on the top and 6s are on the bottom. So I keep my 42 in my denominator. 7 plus 6 is?
13.
13. Okay. Now I've just finished solving my denominator. So I have 1 over 13 over 42. Okay. Now I have to divide my fractions. So dividing fractions, you might have seen it as, the way I learned it was called copy, change, flip. But I think you guys might know it as keep, change, flip. Yes, one of those should sound familiar. Point is, I keep my first fraction, which remember, any whole number is a fraction over 1. I change my division, because remember, it's a fraction is really a division. I change my division to multiplication, and I flip my last fraction. Okay, then I just multiply across. 1 times 42 is just going to give me 42 over 13. So that's part 1 of this problem. Okay. I know, Phoebe, I know, but now it's a little bit easier. Trinity's pulling her hair out. She's going crazy. It's easier, right? I can already eliminate 2 of my answers in question 13. Which 2 can I eliminate?
Sorry, what was the question?
Which options between A through D can I eliminate? I can get rid of 2 of them right off the bat, just from looking at them.
A?
No, not A. Not A, not A.
That is one, Phoebe. C is one of them.
And D?
And D, right? I'm looking for an answer that's going to be a fraction. C and D are not fractions. They're never going to become a fraction. So I'm looking for 42 over 13. Now I only have two options to go through. So which one do I want to start with, A or B? Are you signing?
A.
A? Okay, so we're going to try A first. Alex, turn around. You can't see the screen if I can see the back of your head. So A, so now remember, I'm replacing X with 4. So 2 times 4 plus 5 over 4 squared plus 5 times 4 plus 6. Okay, so 2 times 4 is going to give me 8 plus 5, 4 squared.
16.
Trinity, did you give me the answer for the numerator already?
Yeah.
Okay, I heard it. It was 13. And then 5 plus 4, that's easy. That's 20 plus 6. So I can go on to the side here. 20 plus 16, that gives me 36. Plus another 6, that gives me 42. Do these match? Are they the exact same number?
Yes.
Are they? 42 over 13 is the same as 13 over 42?
Well, no, they're like switched.
Exactly, so they're not the same. So that means my answer is what?
B.
B. So B is my final answer. You can also, when you look at the options, you can kind of figure out that denominator, right? 2x plus 5. That's easy kind of to do mentally. 2 times 4 is 8. 8 plus 5 is 13. So you can already, you don't even have to deal with this polynomial here. You could just also look at the denominator, figure out it's 13, and go from there. Yes? We're good? We are moving on. Number 14. So 14 is, it's interesting. Okay, so 14 says, if 3x minus y equals 12, what is the value of 8x over 2y? I will tell you right now, it is not D. I'm pretty sure we all want it to be D and say there's not enough information and move on. But that's not the case. So we want to kind of figure out how to get these two numbers here to match. Okay. Now, when it comes to our exponents, okay, I froze again. There we go. When it comes to our exponents, right, we have just a regular 2y. Can I change 8 into using exponents with a base of 2? Meaning, can I get something with a 2 down here and a number up here that equals to 8? What is going on in the background? I see someone swinging something around.
Huh?
Someone was just, I saw it in Trinity's camera. Someone was swinging something in the air. Oh my goodness.
Sorry, I have no idea.
I don't know either. I just saw it swinging there. It's a danger. Oh my goodness. Okay, so can anything be 2 with some exponent? Will it equal 8? Well, let's go through. So we have 2 squared which is the same as 2 times 2, which is 4, right? 2 cubed is 2 times 2 times 2. So 2 times 2 is 4, times 2, 8. Done. That's what I'm looking for. Now I can rewrite this as 2 to the third, right? Because this equals this. 2 to the third equals 8. I'm going to go ahead and put this around here, and I'm going to put that x up at the top, right? Because I'm not forgetting about this x. I just need to push it off for a second. And 2y. Now, when I have an exponent to an exponent, so when I have a power to a power, I'm really multiplying them, okay? So I can rewrite this as 2 to the 3x over 2y. Okay, so this, I don't know how much you guys remember. I'm sure we're gonna go through it again. All the properties of exponents, and when you're multiplying by exponents, and when you're dividing exponents and all that stuff. So when you are dividing exponents and they have the same base, it's the same as subtracting, okay? So I can rewrite this as 2, 3x minus y. Yes? We see what I did there. I'm using the property of exponents to change this up a little bit, okay? Now 3x minus y, doesn't that look familiar? Is there a delay in my writing? What is happening? Why can't you guys see me? Hold on, I'm gonna stop sharing the screen and then switch it back because I think it froze up. Yeah, let me. Rejoin the meeting. 1 second, guys. Technical difficulties. Because it kicked me out. I don't know why. That being said, behavior has to be better. You guys, I'm not seeing enough people. And when I am looking at you guys, we're not looking at the screen. We're not paying attention. So something's got to be fixed with that, because, you know, we're doing these lessons. I'm trying to do what I can while over here in quarantine. So I need you guys to try and work with me, okay? Just, we can be a little bit respectful for each other and get through this. It's only 2 weeks and I will be back in the room, okay? If Cameron's computer died, she can sit at someone else's computer to watch. Trying to get through this problem, but my internet kicked out and I don't know what happened. Let's see. See if this works. Okay, I think we're good now. I don't know what happened, that my internet kicked me out for a second. There we go. All right, we should be back. There we go. So this is what I was doing. So once I rewrote it, I had 2 to the 3x minus y. So that should look familiar because we have it right up here. So 3x minus y equals
12.
12. So 2 to the 12. Is that one of my options? Yes. Alex, what are we doing? Because I know I'm really funny, but I know I'm not being that funny right now. Because I just had a
No,
serious
it's just your
conversation
voice
about us
keeps
being
cutting in and
respectful.
out.
It's cutting in and out. Well, I'm recording it, so hopefully the recording should sound better and you guys can watch the video
Okay, got it.
later on. But just try to focus as much as we can now. So my answer for 14 is A. I did property of exponents, converted it to the equation that I knew, replaced it 12, 2 to the 12th was one of my options. Okay. Now number 15. Number 15 is pretty much going to take us to the end of the period. We have ax plus 2, bx plus 7, I forgot an x, equals 15x squared plus cx plus 14. It says for all values of x, a plus, so on the side here, a plus b equals 8. Okay, what are the 2 possible values for c? So, what I'm gonna do here, first thing I do is avoid, everyone's frozen. Okay, do you remember what for first, outside, inside, and last? Use FOIL when you have so I'm gonna go ahead and I continue. It's what's happening. So A and B becomes A, B, and my X's have, so when, okay. Let's see. Let me see. Okay, there we go. Plus CX plus, actually, I need my red, plus 14. So I should have kept them in the purple, but I'm gonna go ahead and use a different color so that we can see. Let's see. So here's my x squareds. Okay. This here is my cx, and this last here, 14 and 14. So because they are equal to each other, you can match up the variables, and those are what they're equal to. So for example, abx squared is equal to 15x squared. Okay, now I can remove the x squared by dividing, and that gives me AB is equal to 15. Okay, now I don't know what AB is, so I need to try and figure that out. So I'm going to go ahead and look back at my second equation that was given to me. A plus B equals 8. Now, which letter do I want? A or B?
I want A.
All right, so we're going to do A. It doesn't really matter. I'm subtracting B to both sides, and A is now equal to 8 minus B. Now I can take this value and replace my A with 8 minus B is equal to 15. Yes? So far, so good? Okay. I'm going to keep going. That's going to be 8B. Wait. No. That's not going to work out so well. Okay, we're not going to have time to finish this problem anyway, so we're going to have to finish it next Friday because we only have 2 minutes left. But we'll go through it and it'll make more sense. But we're on the right track. Basically, you have to change things around, plug in the values, and then figure out your A and your B, and then you can get to the C part. Okay. So once again, no test. On Monday, we start chapter 2, which is on absolute value graphs, which we should already be familiar with. And